So today we're going to learn yesterday or Tuesday. We learned about simple mixtures. Today we're going to learn about compound mixtures. And this is so simple mixtures is when you already know the total amount of stuff. Like you have 60 coins in your pocket. You have 80 hot dogs, I think was an example. Okay, you already know the total. But compound mixtures, you're mixing or adding to create a mixture, so you don't know how much you're going to end up with. So simple, you already know how much you have. Compound, we don't know yet. Does that make sense? So it's the same exact process. You still start off with the table. Then you have A for amounts, V for value, then your total value is A times V. This will be what we fill in from the word problem, and this is your total column. So when I was in school, I took chemistry, and I struggled with these a lot. Probably have seen this in chemistry class. You're taking like two beakers of stuff, and one's usually acidic, mixing them together, and you're trying to create something, and sometimes it like foams up or bubbles over, and you're trying to get like a certain color or a certain pH level. There's a lot of chemistry experiments that go with this. So Jamie was doing a chemistry experiment that calls for a 30% solution of copper sulfate. Okay. And I looked up what is copper sulfate. I had no idea. So I looked it up, and it says that's what you put on grapes to help them not go moldy as fast. Okay, so they put copper sulfate on it so it doesn't go as moldy as fast, which there's a lot of stuff on your fruits at the store. That's why you wash it off. They put it on there so that the stuff lasts longer or keeps the bugs off. So that's what copper sulfate is. Okay. She has mLs. What's an ml? Do you remember? Milliliters, right? Of a 25% solution. How many milliliters of a 60% solution did Jamie add to obtain the required 30% solution? And when I was in school, I'd bang my head against the wall and not quite be sure what to do. Now, what do I put in these two boxes? Do I put copper and sulfate? Do we know which one's copper and which one's sulfate? They don't tell us which one's which. So instead of calling it copper and sulfate, let's make this let's let this be the 25% solution, for lack of better name. And then, so she has a 25% solution, and she's mixing it with a 30% solution. And we don't know which one's copper, which one's sulfate. Oh wait, no, that's a 60%. I read that wrong. 60% solution. So you have something that's only 25% with something that's 60%. You're mixing them together 50%. So do you think you're going to need more 25% 25% or 60%? If you're trying to get to 30. Probably need more of the 25%, right? To get to 30%. So let's read through the question, fill it in. This would be how much you put in. This would be the percent solution, and this is our total. So she's trying to get a 30% solution. That's her goal. That's what she wants as her end result, right? She wants 30%. She doesn't want 25%. She doesn't want 60%. She wants 30%. And for the first time, the 30%, we finally fill in this box. 0.30. That's what we want. She has 40 milliliters of a 25% solution. Well, so this would be 40 amounts, 40 milliliters of a 25% solution. How many milliliters, so that would be my what? My X. How many milliliters of a 60% solution? Percent, how many? And 60% is 0.6, right? Should Jamie add to obtain the required 30? So we don't know how big this mixture is going to be. It's going to be at least 40 milliliters, right? And we're going to add in some more, and I'm going to guess it's going to be around, see if you have 40 to 25, and they're just trying to increase it a little bit, like 10 to 20 maybe, somewhere in there, that's my guess. So what changes in this problem? 40 times 0.25, which means 25% of 40, which means 40 divided by 4, which is 10. We still do 0.6 times x. I don't like the 0, so I'm going to get rid of it. Now, what do you think goes here? Total. If we have 40 here and x here, what would this be? Not 40x, that'd be 40 times the amount, right? But if I have 40 and x, that is 40 plus x times a 30% solution. And I like, well, I guess it doesn't matter. I was about to put my x first because I like the x first. And now I have a sentence I could write out. I have this plus this is equal to this. So 10 plus 0.6x equals 30% of that first mixture and the second mixture. Distribute. 30% of 40, well 10% of 40 is 4, 3 of those would be 12. Plus 0.3x. Bring down my 10 and my 0.6x. And then from there, we're back down to Algebra 1, solving a multi-step equation. So subtract off 0.3x is one way to do it. There's many ways to do this problem. Let's cancel. And then I get 10. 6 minus 0.6 minus 0.3 is 0.3. Subtract 10 from both sides. And you get 0.3x. 12 minus 10 is 2. Divide 2 by 0.3. And 2 divided by 0.3. What is that? Any idea? 0.666666, right? Which is 6 2/3. Now, because I'm mixing things, it's hard for me to see as points. It's easier for me to think of 2/3 full. So 6 2/3, or I guess it's 0.6 repeating, you could. So I need 6. How many milliliters of a 60% solution should Jamie add? Jamie should add 6 2/3 of the 60% solution. Remember I said it was going to be around 10 or 20 at the very most? So 6, that sounds good to me. That sounds about right, doesn't it? I mean, this solution's already at 25%, and you have 40 of those, 40 milliliters, so you're not going to need that much more just to get it to a 30. It'd be like if you're trying to get your grade from a 25% to a 30%. It doesn't take much work, does it? Like one thing you turn on, you get 25% to a 30%. Now, if we were trying to go from like a 25% to a 90%, that would be filling up the whole room probably, get a lot of solution. Questions on that? Next, example is adding water. If you add water to something, water is 0% always. So if you add water to any solution, like this 25% solution, if I added water, that would make it dilute. You ever made grape juice or apple juice? The more water you put in, the less flavorful it is, right? Sometimes like juices from stores or home, so I'll mix it with some water. Let's do that. Too sweet. Anyway, water has a 0% value. And right here, when adding water, the value of the water is 0. Let's make a table. We have our A, amount, our V, our value, our total value, and our total. Mr. Parker has 430 milliliters of a solution that is 24% acidic. How much water should he add to obtain a solution that is 15% acidic? So he's starting out at 24%, and he's going to dilute it to make it only 15%. Well, we have a 24% acid is one of our variables. And the other one is water. H2O. By the way, I looked up copper sulfate. Anyone remember the abbreviation? Science class? Too. Copper. Starts with the C. It's not CO. Cu. Copper. And then sulfate, I had to look that up. I forgot that too. What's sulfate? That's up. And the water, we all know water takes H2O, right? 2 hydrogens, 1 oxygen. So Mr. Parker has 430 milliliters. That is 24% acidic. So amount 430. At 0.24. How much water that'd be X, right? We don't know how much. Should he add to obtain a solution that is Oh, what would I put here in value for water? Water is 0. Good. So anytime you're talking about water, water is a value of 0. So, but he's trying to obtain a 15% acid. He's trying to dilute it. So 15% goes here. Now, it's the same exact problem from here. You're going to take that plus that, put it here. You're going to multiply this way, multiply this way, multiply this way. This plus this equals that, right? Same problem. We've already done this problem. 430 milliliters plus some water. This 430 times 0.24 is 103.2. X times 0 is 0x, which is 0. And then we have 0.15 times 430 plus x. Set up my equation, 103.2 plus 0 equals 0.15, 430 plus x. This is actually an easier problem than before. Water makes it easier. 103.2 plus 0 is 103.2. 15% of 430, well 10% of 430 is 43, and then half of 43 on the 43 is 64 and a half plus 0.15x minus off 64.5. Those don't cross, sorry about that. 103.2 minus minus 64.5 is 38.7. And if you're bothered with the x on the right side, you could flip the whole thing around, right? You could rewrite it like this. Divide by 0.15. I got 258. So you have 430 milliliters. You need to add 258 milliliters of X, which is water, to get a 15% solution. So how much water do you need? Mr. Parker, we'll call him by his name. Need 258 milliliters of water. Right? Does that make sense? Save this paper. Your chemistry teachers do not teach this way. If you take chemistry, you do a lot of this. And had I seen it this way, it would have made so much more sense. I struggled with this kind of stuff. Even in college, when I was a math major, I struggled with this stuff for some reason. It's not as easy as it looks. But if you do the table method, I think it's a lot easier. That balancing equations, for some reason,